સર મારો અવાજ આવે છે? તમારો અવાજ નહીં આવતો. માઇક્રોફોન મ્યુટેડ છે. ના, તમારો કેમેરા કશું નહીં. Okay, we'll start at 3:15.
Good afternoon, sir.
Good afternoon. Just a minute, sir. Is your camera on? Okay, fine, sir. No problem. Shall we start, sir? Dr. Iyer? Dr. Iyer, shall we start?
Good afternoon, Dr. Patel. Can you hear me?
Yes, I can hear you.
Yes.
Am I audible to you?
Yes, sir.
Okay. So shall we start, sir?
Yes, sir. Sure.
So I welcome Dr. Shailesh Iyer for this technical session as 8. Dr. Shailesh Iyer is working with Rai University in School of Engineering as a director in Ahmedabad. His area of research are mainly the machine learning, deep learning, mainly in this pattern recognition and other things. So I welcome you, Dr. Iyer, to this icSoftComp2022. This session, we have 5 papers, and I call first paper is with a paper ID 88. So I will call the author of the paper 88. Dr. Gudla, are you there? Author. Paper 88, author of paper 88, are you there? Sir, am I audible or not?
Yes, sir. You are audible, but I think so. Raju Gudla is muted actually.
Yes, he is.
So the author needs to unmute and then.
Braj Desai, author of paper ID 91. Are you ready for your presentation?
Yes, sir.
Okay. So you just share your screen and start your presentation.
Is my screen visible?
Yes.
Yes, sir. So, shall I start, sir?
Yes.
So, my name is Raj Desai.
You will get 10 minutes
Yes.
to complete your presentation, which is followed by question answer of 4 to 5 minutes.
Okay, sir. My name is Raj Desai, and me and my mentor, Pallavi ma'am, has worked towards this topic of analog implementation of deep neural network. And today I will be conveying the following contents towards the topic, sir. The main motivation towards developing such circuit was, as we can see, that various digital ASICs have been created for implementing matrix multiplication, which is the fundamental process for neural networks. And as time has gone on, the the neural networks have become ever larger, which require large computational need on digital circuits. And due to slow development in scaling down the transistor, we are not able to increase the computational density of the chip. So that for that, what we have created is the basic analog circuit, as we can see here. On the right hand side, we can see that there is a basic. There are two ways just to show up what is a basic neuron made of. It is made up of an input value. Here we can see V1, V2 up to n number of input values which are multiplied with the weights, and at the input of a neuron, it is added and applied to the activation function for such that we can perform this task very easily in analog circuits, in which we can use resistors, as seen here, W00, W10, and W20, which act as a multiplier unit. The input voltage is applied and the current are added at the node and applied to the activation function circuit, that I will show later on. That again we can apply back to the current stage or the next stage of the neural network, sir. So this is a basic voltage buffer circuit, which we have created using 16 nanometer transistor model, in which we can see the R1, R2, and R3 are resistor values, and to get the resistor value, the basic equation was derived, in which voltage plus error divided by voltage into weight. The voltage into weight is the multiplication that is being carried on, and the error, if we are able to design a voltage buffer such that the loss across it is very low, we can eliminate the error and we can directly get the value of the resistor, which is 1 by weight. So that we can just place this voltage buffers for input, so that the row values of resistors do not create a loading effect on the op amps, which will be of the previous layer. Here I would we have created a two-stage transimpedance amplifier using operational amplifier, in which the inner first stage, which is shown by inner transistors, has a cross coupled load for high gain, and the outer stage, which has a active load for single ended output. As we can see from the previous slide, the I add current is applied to the input of this transimpedance amplifier, and the output we get the one-to-one correlation of the voltage. So again, this voltage can be applied at the input of this CMOS rectifier which we have used. In this CMOS rectifier, we can see on the right hand side the graph that over the NMOS side, which we will get the negative outputs, negative rectified outputs, and on the PMOS side we will get the positive rectified outputs. We are using both. In essence, we only require the NMOS side or the PMOS side. But uh, for uh, for removing a complete stage of op-amp, for converting to positive negative, what we are doing is in every odd layer, as op-amp is giving us negative gain, we are just taking the negative rectified output and providing it to the even layer, and in the even layer we will be taking the positive output. So here we can see the complete circuit in action, in which the three cross one matrix multiplication, in which we have used three voltage buffers. The input values VA, VB, and VC are applied to the voltage buffers, which will be obtained from the real world or analog to digital to analog converters, or the previous stage. Then which will be converted to currents, weighted currents, and added at the node. The current will be passing through the feedback resistor R1 and applied to the CMOS rectifier, in which we will be taking the output from the NMOS side. As we can see in the operation performed digitally, the output should be of this operation should be about 62 millivolts, and the circuit is able to generate about negative, but about 62 millivolts, sir. Uh, for negative edge, what we have done is we have added PMOS stages, and we can see here that we have applied VA to be negative, so we have used the PMOS, and for also controlling zero weights, we have added a pass transistor which we can control individually. And here we have created a 3 cross 3 matrix multiplication just to showcase that the circuit can be scaled very easily, in which all the transistors of one column are added and provided to one transimpedance amplifier, and each column will have its own transimpedance amplifier and the activation circuit itself. And again, the circuit, as we can see from the values, it is able to uh, accurately recreate the output voltages with a bit of error, sir. And here we have also implemented a two-layer recursive matrix multiplication, in which the first stage will be provided again from the input from the real world or the analog converters or the previous stage, and the output of the first layer is given to the PMOS layer, which is the even layer, and the output of the the final output, which is calculated by the circuit, as we can see, V out A, V out B, and V out C. It matches the output of which is calculated using a calculator with a bit of error, sir. So, uh, and in conclusion, what I would like to add is, in conclusion, that when we calculate the number of transistors of 16 nanometer PTM model we have used compared to the 8-bit Vedic multiplier, which is the fastest multiplier available in digital, we are able to reduce the transistor count about 89.98%. While we have observed that the power consumption has increased, but the overhead of adding more number of calculation compared to digital is reduced drastically, and the power consumption can also be reduced by improving the architecture of TIA or the voltage buffer. Uh, and we the output is also output has seen that it has a bit 1% of error, but the error can be eliminated as if the neural network is trained in the presence of noise. The error which is generated by the circuit can be eliminated, and also the error averages out over the positive and negative side. The circuit of two-layer 3 cross 3 multiplication is also works up to 61 megahertz. Sir. This is my presentation, sir. Thank you, sir. And I would like to ask for questions, sir.
Yeah, Raj, actually, it's good work that you have reflected here. But one question which I want to ask, just go to the previous slide, last one. Yeah, you have mentioned that we are reducing the minimum transistor, reducing the transistor count by 89.98%. So is there any
Yes, sir.
other overhead that is added because of this? Because if you're drastically reducing something like this, the transistor count, it should lead to some other effect where we have to increase something or some kind of load needs to increase or something like that. So is there any kind of additional burden or any lower parameters that we are getting as per the performance is concerned?
Uh, Additionally, the surrounding circuits might have to change, sir, because the speed of operation while converting from digital to analog is at the time is very slow, sir. So I think that might get affected over here, sir.
And what are the other parameters that you have checked for? Like, I mean, how
Uh,
your
yes,
architecture is better compared to other existing architectures?
actually that part is not. Right now, I have not observed other architectures, sir. I'm really currently working on it, sir.
Okay, because you will have to reflect that also, because if it is going to give you an edge over, I mean, your architecture is better compared to the existing ones, or if it's a hybrid architecture that can be better also, and that can be considered. So you
Yes,
can
sir.
work on that, but it's a good work actually, and you have concentrated upon the actual work done. So that is a good thing. that I found in the presentation.
Thank you, sir. Thank you, sir.
Any question from the audience? Anyone has any kind of query or questions? Okay, sir. Shall we move to the next paper, sir?
Yes.
So next paper is
Sir?
yes.
Sir, I would like to thank all the committee member of the conference for giving me such a stage to work on, sir.
Okay, thank you.
Thank you, sir.
So next paper is paper ID 102. Author of 102, Satvir Singh. Are you there?
Hello, sir. I'm here.
What's your name?
My name is Satvir Singh, sir.
Just a minute. You are the presenter right now. You can start your
Yes.
presentation. You can share
Yes, sir.
your screen. Yes, we can see your screen.
Oh, okay. Thank you, sir. So, hello, everyone. Thank you for this opportunity to present my paper, Designing for Device Network for Digitization of University Campus in your conference. So, these are the contents which I will cover in this presentation. So, first of all, I would like to start with the introduction of cloud computing. Cloud computing is a well-known term for everyone in this era of computers and digitalization. So it is a method of accessing information and applications over the internet instead of keeping and maintaining them on the personal systems. A person can access the cloud services like stored data, applications, development tools from anywhere and anytime using the internet. The cloud service providers store data and applications at a centralized location that is known as the cloud data center. And these data centers are situated very far from the common users. Therefore, the limited demands or the time constraint demands of users are not profitable for the cloud service providers in terms of the time and cost. Recently, fog computing has been emerged as an advanced computing technology for processing the limited and time-critical demands for the consumers. It is an extension of the cloud services at the edge of the network in terms of fog devices. The fog devices can be like smart routers, switches, the limited capacity machines, etc. The fog computing architecture is a decentralized architecture and it is heterogeneous in terms of its functionality and the capacity. Here we can see the network diagram of fog integrated cloud environment. In this architecture, the first layer includes the user applications with internet connectivity. The layer 2 consists of multiple heterogeneous fog devices with limited storage and capacity. And these fog devices can communicate with each other on local area network and need a wide area network to communicate with the cloud data center. The cloud infrastructure layer consists of a centralized data center, which has multiple physical machines with an extensive capacity of storage and processing. So we can see the integration of cloud and fog computing offers a suitable and viable architecture to handle every type of request. And in this, our proposed model, the cloud data center can be used as a backup machinery. So in this state of art, many researchers have developed several models to digitalize and make smart the health related services. They have placed smart gateways in between end devices and cloud data center. Several smart parking models are also proposed in various papers. Using these smart parking models, they have reduced like maximize the profit of parking authority. In smart waste management, various techniques are used for waste collection, like dissecta or single sort pass algorithm are used, and overflow can be checked using this smart waste management. Various researchers also proposed their model using mathematical formulation and by considering various objectives like the cost, the energy, etc. They use their model to find optimal placement location for the fog devices. So now I would like to discuss some preliminaries of the proposed model. In this proposed model, there are some set of network entities like user request category, which is basically used to group the request received from the users based on the fundamental services offered by the university in our case, like library, hostels, administrative related request, hospital, and the canteen. There are some parameters of user request category like RAM size required by the user, secondary memory processing elements means number of cores of a machine, number of requests, average request size, link capacity, and the packet size. Similarly, the fog devices are heterogeneous in processing and hardware configuration. Though that's why the fog devices are also categorized based on the parameters which are shown in this slide. And the different type of connection links are considered in this network design to connect fog devices with the cloud. There are certain possible placement locations we have considered, and their coordinates also considered in this model, and the respective cost of the placement location is also considered. We have considered two constant values. One is speed of light as a velocity, and 1% as a average percentage of traffic going from fog devices to the cloud or the central information system. And one equivalent distance function is also used to calculate the distance. The four decision variables are used here, A, B, C, and D. The first decision variable tells that if a fog device is placed on a placement location, then the decision variable A will be 1, otherwise 0. B will be 1 if a user request is served by the fog device placed at a placement location. Similarly, the C decision variable will be 1 if the user request is served by the cloud. And the last decision variable is a D decision variable, which will be 1 if a placement location is connected with the cloud using the link L, type of L. And we have considered two objectives here, and both the objectives are need to minimize. The first objective is deployment cost. The deployment cost will be calculated by adding three different type of cost. First one is the fog device cost, which is going to placed on the placement location, and the placement location which is used for the placement, and the link cost which is used to connect the fog device to cloud. And the second objective is the traffic, which will be calculated as like the request which are directly going to the cloud for the service, and 1% of request going to fog, because some portion of the request will be transferred from fog devices to the cloud for the analysis purpose. There are some constraints which are subject to this proposed model. The first one is the unique fog device placement. It means on a placement location, only one type of fog device can be placed. Second constraint is the unique service provider. It means is request is serviced by either a fog device or by the cloud. Unique link placement means only one type of link can be used to connect fog device and the cloud. Similarly, the PE capacity, RAM capacity, and secondary memory capacity tells that the capacity required by the user must be less than the capacity the fog device have or the cloud have. The inventory capacity means in our budget we have limited number of fork devices, or we want to place limited number of fork devices to reduce the cost. That's why the inventory capacity is here and the link capacity is also. Now the proposed solution, the proposed model will be solved using the multi-objective weighted sum approach. So this classical method converts a multi-objective problem into a single objective function using weight coefficient of each objective. So our objective will be look like this. Both the objectives are normalized because the range of the objectives can be different. That's why we need to normalize them. To normalize both the functions, we use these two methods which are very popular. So, and the weight coefficient must be, the sum of weight coefficient must be 1. So next, this is the proposed flow chart of this solution. First of all, we set the values of W1 and W2. W1 W2 are the weight coefficients, and then we solve our fork device network design problem, and we get a solution, and that solution will be put in the Pareto optimal set, and we check the termination condition. If the W1 is 0 or W2 is 1, then we terminate here. Otherwise, we reduce the weight and solve for the different combination of weight, the fork device network design problem. After terminating this process, the Pareto optimal set will be generated, and we can easily choose the best optimal solution from the Pareto set. The experimental setup. So the experimental setup is developed on the IBM iLog Simplex optimization studio, and there are some input parameters which are described in this table 1. Here there are some parameters of the user application cluster. So table 2 and table 3 describes the characteristics of fork device type and the communication link type. Here the input values we have considered in this experimental setup are described in this section. Now the parameters of possible placement location, where the coordinates which we have considered in this method, like coordinate x and y, and the cost related to the possible placement location. Here is the Pareto optimal set using the weighted sum multi-objective optimization method, where we have two weight coefficient W1 and W2, and there are different combinations which are possible of these two weights. And there are 5 data sets which are used to generate the output, R10, R20, R40, 80, and 160. It means R10 have 10 requests, 20 have 20 requests. Similarly, 40, 60, and 160 requests. In this table, we can see that the green field, the green values which are highlighted are the minimum value which we get the objective output after the solution after executing this proposed model, and the red the red marked values are the maximum values. So it is easily can shown that weight 1 is 0.1 and weight 2 is 0.9, which will better in this RF scenario. So these are the experimental results in the graphical form, where the different data sets are here, and the minimum optimal value, average optimal value, and maximum optimal value are shown. So at the end, I would like to conclude this presentation with the conclusion remarks. The first one that as we discussed, a linear mathematical formulation is developed in this paper to solve a fork device network design problem with an application to university campus digitalization. The proposed solution finds the optimal placement location for fork devices, their capacity, and the connection links which are used to connect fork devices to the cloud. The two objectives are considered here: the deployment cost and the traffic. Both will be both we are going to minimize. The multi-objective optimization problem is solved using the weighted sum method, and the IBM Simplex optimization tool is used here to evaluate the proposed optimization problem. And the experimental results exhibit that the optimal placement of fork devices with minimum deployment cost and the traffic is achieved. So this is from my side, and these are the references which I have covered in this, which I have referred in this paper. So thank you for listening, and feel free to ask any.
Yeah.
Any.
Again, a good effort. Actually, just one question from my side. What is the
Yes.
data set that you have considered for the
Actually,
university?
the data set is generated randomly. We have the input values which we have considered here are shown in the cell in the presentation, and the user requests are generated randomly, in which we can analyze the results. Yes. Hello, sir. Is it audible?
Yeah, now
Yes.
audible.
Yeah. So I'm telling that the data set is generated randomly for the user request, and the parameters for the network entities like fork device type, communication link, and the placement locations are uniform for all the data sets.
Okay. Now, what I mean to say here is that if the number, I mean, for if you're deploying it for a university, what are the specific parameters in terms of the data set and size of the university? Does it matter actually in this?
Actually, this model is just a prototype of a university digitalization, so we consider it hypothetically.
Okay, so I think if you go forward with this, you will find some roadblocks for which you'll have to think for some solutions, because when you go for actual implementation, you'll find many roadblocks in terms of a lot of parameters you need to include still into this. But otherwise, a good
Yes.
effort, I think so. I mean, it requires a good amount of effort to encapsulate all this and work on this. It's good effort
Yes,
from.
sir. Yes, sir. Thank you, sir.
Any question from the audience? Shall we move to the next paper, Dr. Iyer?
Yes, sir.
So next,
Thank you so much, sir, for the giving this opportunity to present here. Thank you so much.
welcome. Next paper is paper ID 154. Soumya Ghosh are, I think, present here.
Yes, sir. Yes, sir. Am I audible?
Yes, you are audible. You are to
Okay.
present.
Right. Let me share my screen.
Okay. Meantime, we can also like 88. I think so. Can be kept on if the author is ready. We can take it next also if possible. The first paper that we,
I think he is not right now here.
because he's
Join
connected, but yeah,
the
he's
meeting,
in the meeting.
not physically present. Okay. Soumya Ghosh, you may start.
Yeah, just a minute, sir. I'm sharing my screen. Just a
Okay.
minute. Is my screen visible?
Yes.
Okay. Uh, Thank you for giving me this opportunity to present my paper in icSoftComp
Please
2022.
switch to the
The
presentation.
paper,
Turn to the
yeah,
page.
I've made it full screen.
Okay.
Is the
No,
slides are changing?
No, I can see the first slide, titles.
And that too, it's not full screen actually.
Yeah, I've made it full screen.
Think there is some like technical problem or yes.
Yeah, just a minute again. I'm trying. Is it now full screen?
Not in a presentation mode, but it's in a full screen.
It's showing 60% actually here. You can just zoom it to 100% probably.
Or it's fine, no problem. You may continue.
Okay, okay. And the
Just
slides
go
are
to the,
changing, right?
just go to the next slide. Second slide.
Right. Yeah, I've gone to the next slide. That is overview slide.
I think we can see the first slide.
First slide only. Actually, you can just make it 100% because I think so. I can see it as 60 something, 60% only. So if you make it 100, and then probably go, yeah, then go to slideshow probably.
Is it now visible? Is it now changing the slides? Okay, then I'm just presenting in normal mode. Hello, is it
Yes, you may start.
okay? So thank you for giving me this opportunity to present my paper. The title of the paper is on language clustering, a non-parametric statistical approach. This paper is written by three two others co-authors as well. One Anok Chattopadhyay from ISI Kolkata, and Dr. Samit Karmakar from Jadavpur University. So Anok is also here with me in this presentation as well. So in this presentation, we'll be talking about this following topics. We'll start with the data clustering techniques. Then we'll be talking about the methodology, data collection part, data depth and linguistic clustering that we have done over here, and then we'll go towards the discussion and finally the reference section. Now, when we are dealing with this data clustering part, the first thing that we need to focus, or the goal of this entire data clustering, is to divide a set of n items into groups. So if we just represent it in a similarity matrix of n into n, then we will have this dimensional space of d, and there we can have this entire cluster data. And this data clustering can be divided into two parts. One is a parametric method, and the second
So,
one is a
sorry to
non-parametric.
interrupt. Yeah,
Yeah.
sorry to interrupt. Actually, I just want you to remind you that you have 10 minutes. So probably try to keep it the important part only because I think so the introduction can be skipped if not
Okay.
that
Okay. No
important
issue,
yet.
sir.
And I
Okay,
see
sir.
your 25 slides.
Uh,
So we would like to go to the actual work part so that you can concentrate more on
so
that.
lots of slides are data centric, sir. Okay, I'll try to keep it short. No issue, sir.
Fine. Thanks.
Okay, so in this data clustering part, normally basically we are following two parts. One is in this parametric method, and the second one is non-parametric method. And as we all know, the parametric statistical technique is basically assumes the existence of a fixed number of parameter model, which basically describe the probability distribution of a data structure. And this is basically if we go through the literature, this factor, it is really hard to model the structure of languages. When I'm talking about languages, it is the natural languages that we are talking about. So these methodologies that we are talking, that parametric, this have a scarcity in the literature, and it is really hard to model the structure of languages parametrically. So therefore the main limitation of this method is, then first don't have a very sufficient data. There is a lack of appropriate parametric model structures and suitability as well. So these are the limitations that we have faced, based on due to which we have shifted to the non-parametric clustering. And the non-parametric clustering, the main factor, if we just point out over here, that it doesn't assume the existence of a fixed number of parametric model. And this methodology is particularly, however, more common in literature due to the fact that it is taking the data for its face value and it's not assuming the underlying distribution structure. Now, if we go through the literature a bit, we will see that the bottom up agglomerative clustering, which assigns each data point in its own cluster and iteratively merges clusters such that the sum of square distance between points within all clusters is minimized. And PAM based approaches particularly is also common in this entire non-parametric domain. Now, the question that come up in our study is that why particularly we are focusing on this parametric approach. Now, in non-parametric paradigm or this non-parametric approach, this thing is more useful as it allows the clustering and classification without having to specify any parametric-based distribution model. And this common clustering classification techniques like DB-scan can be used in non-parametric paradigms as well. Apart from that, there are other table-based approaches which have been described in literature that we have also mentioned in our reference section as well, that may remark on this non-parametric classification based on data depth and suggest a first classification approach with the statistical approach. Uh, and apart and additionally, we can also see that this aids us in developing statistically sound methodology. And for this part, we have used the software and spatial depth functionality in order to have this non-parametric domain. Now, the methodology part. In the methodology section, what we have done, we begin by creating sets of most frequently used term in languages. And for that, we have focused on this Romance language particularly. After that, in the second step, we have calculated the distance matrix that is relating to the distance between any pair of languages. And then we have calculated using this Levantine distance matrix. This stage layers the groundwork for creating a language space with the right amount of dimension. After that, we have done this dimension scaling, which is done. We have followed this multidimensional scaling or MDS. This creates an entire language space, and finally, the current work then embeds the points belonging to various languages in an abstract Cartesian system that will come in this within 1 or 2 slides. The primary data collection that we have done is from the corpus of 2021, and also we have consulted the database of Swadesh, which is 1955 database. The server corpus is basically contains the most common words, as we all know that it is basically focusing on the common words particularly used in Romance languages. And the data set is mostly like this. We have given a peek of the data set, whereas in the main paper we have given the entire data set. Now I'd like to invite Onok to represent the this section from the paper. Onok, are you there?
Yeah. Hello. Am I audible? Hello.
Yeah, you're audible. Please continue.
Yeah. So basically, what we are trying to do is that we have for each language the most common representation of a particular word. For example, for a word such as bark or say belly, we are using the most common word in that particular language, and then we use this Levenstein matrix structure to be able to describe a distance between these languages. So what I mean by that is that we are defining or quantitatively understanding what is the distance between these languages in a typological basis, and we are doing so by using the Levenstein distance, which is nothing but the minimum number of deletions or additions or substitutions which can be done between a string to convert it to another. Now this distance matrix structure is can we go to next slide, Shomuda? Yeah. So now the problem which usually arises is that if I use a single word to make this distance matrix, it might be quite non-robust in the sense that, for example, if I use a word such as mother, we can see that in various non-related languages as well, we can see that the word usually starts with M and so on and so forth. So these can usually cause a bias, and to overcome this bias, we use a large number of words, and then we average out these distance matrices to be able to get a more robust understanding of the distance. So we can in our paper we have also shown in how in a law of large number basis we can also study statistically show, and using some assumptions, that this distance matrix, which is a average of all the component distance matrix for each of these words, is actually converging to the absolute distance matrix in an asymptotic manner. So in this particular slide, you can see that just a snapshot of some languages and the distances between them. So we can usually see that with languages which are closer, the typological distance between these languages would be lower, and otherwise for the other side. So next for the next slide, Shmuda. Yeah. So now we introduce the concept of data depth to understand languages and to induce a structure of clustering into it. So what data depth does is that, since we are working in a non-parametric approach, hence what we do is that we are trying to understand in some quantitative sense a degree of centeredness or outliningness of any point in that particular data set. And to be able to do that, data depth is a non-parametric technique, which Shomoda also emphasized, that actually helps us understand without any usage of any parametric approach or any distributional assumptions, the actual centeredness or the outliningness of any language. So this data depth structure, which has been introduced in 1992 by Liu, and his consequent works have thus been very important in this particular approach. So we use data depth, and next slide, Shomoda. So what we do is that we have all these languages, about 60 languages, and then in this Cartesian plane, we in a 2D plane, we plot these languages, and then on the basis of the data depth structure, we have been able to introduce a sense of the centeredness of the data of a language. So for example, if I have a group of languages, I can say that this particular language is in some sense the center of this group of this cluster. And similarly, if for an outlying language, such as for example for the Romance language, Sanskrit or Hindi might be outlying language. So we have shown that indeed by using depth type methodologies, we can statistically test and show that that particular languages are indeed outlying to this particular cluster. So this methodology, first of all, is extremely important towards understanding the actual outlyingness of a particular language, and can be used to recognize new languages. For example, some languages which are rare, if we want to understand if it belongs to a particular language cluster or not, this can be very useful. Next slide, Shomoda. Yeah. So no, next slide. Yeah. Yeah.
You are requested to conclude your paper in 2 minutes.
Yeah. Okay. So so this is what we were talking about regarding the typical observations and the outlier observations, and this is the main usefulness of the data depth structure. Can you go to next slide, Shomoda? Yeah. So in this particular slide, we can see that after using this MDS technique, we see that these are the languages in their embedded form, in which they have been embedded into a 2D plane. And we can see that if I use a point such as that corresponding to Hindi or Sanskrit or Bengali, these languages are actually quite outlying. Whereas if you see a language such as Latin or classical Latin, which has been considered to be one of the originating languages of the Romance family of languages, it can be seen that it holds a much more central position corresponding to the Romance cluster. So this particular work, first of all, helps us understand the position of languages in any language cluster. Next slide. Yeah. So in conclusion, we can say that first of all, this work demonstrates the usage of non-parametric approaches, which has not been used till now, towards understanding and clustering, as well as in our work, in our paper, we have also shown the various clustering approaches where between East and West Romance languages, we are able to efficiently cluster the languages using non-parametric approaches. So this work helps to understand the usage of non-parametric approaches towards understanding the position of languages in a language cluster. This work also demonstrates the utility of Levenshtein distance based structures, but also we can furthermore explore other edit distances which can be used to understand the behavior of languages. And not only that, in some sense the evolution of the languages as well, because it can be seen that the languages which are central according to this data depth structure are usually the one which are the older languages. So this is an interesting avenue of research, and can be quite interesting in future corresponding to historical linguistics. Yeah. Thank you.
Yeah, interesting work. But actually, I have one pertinent question. I mean, though it may seem a little bit irrelevant, but why choosing this particular topic of romance? I mean, because
Yeah.
it can be expanded to many other domains also. But how
Yeah.
this came to your mind?
So basically, the data corpus corresponding to Romance languages is quite large because Romance languages contain all European languages, and so they are much more well documented compared to these in Indo-Aryan languages or Indic languages. So in that case, the uh, access towards this corpus was much more easier than looking at other languages. Although this work can actually be increased to various other language clusters as well. That is true. But for
And
this work,
additionally, yeah,
yeah,
and additionally, we are trying to compare this entire language system, like Indo-Aryan language and the Romance language. So we have started with this Romance language, that how machine is actually interpreting them, and sequentially we will move to other language families as well, like one by one, so that we can see that which one is more closer to the other, and in that way we can create that multidimensional domain.
Okay, fine.
Any
Any other
question?
question? Yeah.
Okay, thank you very much, authors. So, Dr. Iyer, shall we move to the next paper?
Yes, sir, sure, sure. Sir.
Dr. Sila SB, are you there?
Yeah, I'm present here.
Just,
I am present here.
just a minute. I'm making you the presenter so that you can.
Yeah, yeah.
You are now presenter, so you can share your screen. You are requested to complete your presentation in 10 minutes.
Yeah, sure. Good afternoon, everyone. Myself, Dr. Sheila. I'm professor in the Department of Information Science and Engineering, BMS College of Engineering. I would be presenting my work on convolutional neural network approach for iris segmentation. My other co-authors are Abhinand P. and Dr. Radhika K.R., who have contributed for this work. Uh, so as we are aware, CNN has been a dominant machine learning approach for classification and regression tasks. Over the past few decades, it has found many applications in image segmentation and many handwritten signatures, speech analysis, classification of images, detection of objects, and various other arenas. Some few examples of CNN architectures are VGG, ResNet, AlexNet, GoogleNet, and DenseNet. The main advantage of using CNN over the past few decades are the pre-processing operations are very much reduced. The training is very simple and it uses fewer parameters. High-level features are extracted, providing wholesome understanding of the images. And in this particular work, the CNN that is being implemented is the semantic segmentation or the SegNet. The categorization using semantic segmentation is based on pixel-wise labeling. That means every pixel will contribute for some label. So in this example or in this particular work, iris and background are, because it mainly concentrates on iris segmentation, iris and background are the two labels identified, and this has been done using the MATLAB software, where we try to recognize or where we try to identify the each pixel, whether it is an iris or whether it is a background. So input to the convolution layer are the images, and a combination of convolutional operations, activation functions, and the pooling layers together will contribute for learning the parameters. Suppose we have the low resolution images or the disadvantages of the earlier techniques like region selection, threshold based approaches, region growing, all that has been the disadvantages has been overcome using this particular convolutional neural networks. In this particular work, we are training the CNN for the encoder depth of 2, 4, and 5, the details of which will be discussed in further slides. Then the segmentation results are compared using the Jaccard coefficient. This is some of the previous or the existing work that has been carried out in iris segmentation. So few of the works, all these are very much related to how the image segmentation has been done for the iris images. So few approaches are parameterized approach for segmentation using RefineNet, then CNN using dense blocks, that is the dense net. So 5 dense blocks are used for encoding and decoding by Arsalan. Then similarly, we have other convolutional neural networks which has been used. A combination of AlexNet, VGG, GoogleNet, ResNet, and DenseNet has also been implemented. Then dilated convolution has been used by Zhang. Then the work by Chen, they use the dense network. Then we have the work by Liu, where we have a combination of capsule network and the convolutional neural networks. Then the few adaptive segmentation also has been implemented using UNet, so which is a unified multitask network also has been implemented, and other networks like Gabor-Trigen network and code-specific device band networks has been implemented by we and the other authors. In the proposed system, which has been implemented by us, we have a block called as encoder block and the decoder block. The encoder block and the decoder block are structurally similar entities. This particular encoder decoder network is very much similar to the VGG16 architecture, which is a pre-trained existing architecture of CNN. So in this particular architecture, the encoder block and the decoder block are structurally similar entities. The encoder block consists of 3 layers, that is the convolution layer, batch normalization layer, and the ReLU. ReLU is the rectified linear unit. So the convolution filters are of size 3 cross 3, similar to the VGG architecture. The number of filters determine the feature maps or the channels in the output of the convolution layer. The number of weights is equal to the dimensions of the filter and the multiplied by the number of channels. And every time the mapping is such that it is based on indices. So the order of the layers in encoder is convolution, batch normalization, ReLU, and pooling. So pooling is mainly used for downsampling the image size. Similarly, in the decoder, we have upsampling, unpooling, convolution, batch normalization, and ReLU, where mainly the unpooling is used for upsampling of the images. So in our iris segmentation, we have implemented encoder depth of 2, 4, and 5. So this particular architecture is showing 5 encoder blocks. This will be followed by symmetrical 5 decoder blocks. So here the activation functions in each layer is mentioned, or it is shown the images. As we can see in the higher level layers, the colors and the edges are, which are simple features, are learnt in the initial layers. As we go deeper, or as we go channel wise in the deeper layers, the eyelashes, the iris, the complex features are learnt in the deeper layers. So convolution is always performed using the learnable parameters. So so one feature per channel is generally learned to extract the useful features. Batch normalization layer normalizes the activations and the gradients propagating through the network. Always we try to concentrate on mean and variance such that we try to optimize for zero mean and unit variance. The ReLU is the rectified linear unit, which is the activation function that is used, and it has proved several times that ReLU has better performance and generalization aspects. So the activation functions, as we can see, the more prominent features are extracted in the deeper layers. Next, we see the details of each layer. So as I mentioned, when we try to implement using the encoder depth of 2, 31 layered network is generated. Using the encoder depth of 4, 59 layered network is generated, and encoder depth of 5, 91 layered network is generated, which is similar to the VGG16 model. So here we also use what is called as the max pooling layer, which is used for downsampling, and the stride of 2 is used, and we also have the padding here, the 1x1 padding which is used. And as we see here, initially the number of filters, it starts with 64 and it keeps on increasing, and the image sizes keeps reducing for each pooling layer. So for the first pooling layer, we can see the reduction further, and after the pooling, after the fifth encoder block, the decoder block, we have the upsampling followed by the decoder, followed by the convolution, batch normalization, and the rectilinear unit. So the proposed system consists of the 31 layered, 59 layered, and the 91 layered networks. And we have the stochastic gradient descent algorithm is used with momentum for training the network. Backpropagation algorithm, optimal learning, regularization factor, and the softmax function. These are all the part of the CNN training. Finally, we try to measure the similarity between the ground truth mask and the categorical images. Categorical image is nothing but the image which we obtain after semantic segmentation. Ground truth mask and the input images are together used for training for the semantic segmentation network. Then the Jaccard coefficient is used here, which is the ratio of the intersection of two images to the union of two images. This is the score that is used to identify the segmentation result. Then Jaccard F measure is computed from the Jaccard index using this particular formula: 2 into I divided by 1 plus I, where I will give us the ratio of intersection of two images to the union of two images. That is the score that is generated. Coming to the algorithm, so initially when the program has been implemented using MATLAB, so some of the code related to the MATLAB has been mentioned here. So first step is reading the images from the data store. So the class names are categorized as iris and background. So in the databases which I have used, UBIris and the CASIA, which are the publicly available iris datasets. So in these datasets, the ground truth images and the ground truth images has the labeling done. So we have the iris and the background labeling which has been done. Then we partition the samples using the 80-20 rule, which means that 80% is used for training and 60% of the images are used for testing. Then segment layers for semantic segmentation uses the VGG16 pre-trained model. Then the training options are initialized with momentum, learning rate, epochs, and regularization factors. So we can see some of the initial values: momentum set to 0.9 and the learning rate 0.001, then regularization factor and the number of epochs is 50, batch size of 32. These are all the initial values which is set for training the network. Then we train the network for using the data set. Then the semantic segmentation is used, where we give the test images and check whether the segmentation has been performed with more accuracy. And Jaccard coefficient is used for measuring the similarity. Then the evaluation metrics like mean IOU value or the weighted IOU value, and the classification accuracy for iris and the background. All this is computed using the evaluation metrics, which is obtained using this particular function.
Dr. Sila, sorry for interrupting you.
Yeah.
Please try to complete in 2 minutes.
Yeah. This is 2 more slides. That's it. So finally, coming to the experiment. So as I mentioned, we have already, I told you we have performed this experiment on UBIris and CASIA. UBIris is a data set which has 522 subjects, each subject having 30 images with 15 images captured in 2 sessions. The resolution of the images are 300 into 400 image size. The CASIA iris interval consists of images from 249 subjects with a total of 2,639 images. So obtaining after the training has been performed, these are the results that has been obtained. So as we can see, the iris has been very clearly segmented, and this is the state of art comparison which has been done. So using compared to the other methods which has been earlier discussed, and the databases which has been earlier done, the work done by others, the proposed model using segment shows promising results. So for UBIris, 0.987 is the F measure, and using CASIA iris interval, 0.962 is the is the F measure that has been obtained. So to conclude, this is one of the most considerably a simple and robust approach has been adopted for pre-processing without using any pre-processing, using semantic information. So pixel-wise categorization has been done, so the accuracy is more precise. The results obtained are more promising. So in future, the segmentation results can be applied to many of the applications which are gaze contingent. That means using the real-time gaze, you are using real-time gaze data, like we can use, or the eye tracking framework, we can apply this particular segmentation for any of the gaze contingent applications and 3D eye tracking framework and all that. Then further, along with the iris, we can also have the periocular information, which is which is a region covering the eyes. So this can actually assist even the iris recognition for many of the security applications, and under the non-ideal scenarios, considering the visible light apart from the infrared images. So this concludes my presentation. Thank you for listening. Any questions you can ask.
Can you go back one slide?
Yeah. This one, sir?
Yeah. Actually, the first paper that you have discussed here, I mean, you
Yeah.
compared, that also gives a very good accuracy of 0.98.
Yes. Yes.
F measure is 0.984.
Yeah.
So have you considered any hybrid method with your proposed method, which
No,
using
this method actually I could not work on any of the hybrid models. Right now I have used only the semantic segmentation approach using the VGG16. Further, I would like to work using a combination of networks, like using DenseNet and using SegNet together. So I'm still in the experimental stages. It has not been completed.
Okay, you can use RefineNet also because it is giving 0.98.
Yes, yes,
That is
yes,
somewhat
yes.
commendable compared to others.
Correct, correct. I would like to implement, but I've still not worked on this scenarios.
Okay, okay, fine.
Thank you, sir. Thank you very much.
Any question from the audience? So, Dr. Iyer, would you like to conclude the session, or if you have any kind of suggestion?
Yeah, I think so. Actually, our one for the initial first paper, the person is not connecting, author is not connecting.
I think the author of 88 has presented yesterday.
Okay, okay, fine, 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 great. Yeah, actually, it has always been a pleasure to be connected with Dr. K.K. Patel and also with Charu Set for any of the conferences or any of the connections that we are together with. So I congratulate Charu Set and the organizing body, entire organizing body, uh, for making this conference a reality. And I think so a lot of efforts have gone into it. What I find is that once the conference is over, the next conference preparation starts. So that particularly effort can be seen in the entire work that we are seeing right now. And also the quality of the papers is also very good. I mean, whatever we have gone through right now in this these four papers were very good. And I think so. These are all papers which actually are not just review papers, but they are giving some kind of proposed work and they're comparing it with the proposed work. So overall, I think so it's a very good effort from all the authors and I wish them all the best. And thank you very much, sir, for inviting me. And it was really pleasure being a part of this conference. Thank you.
Thank you, Dr. Iyer. Thank you very much for sparing your valuable time for icSoftComp 2022. And I would like to thank all the authors for submitting their papers to this icSoftComp 2022. This time we had received 341 papers, out of which we have selected 36 papers with around 12% acceptance ratio. I would also like to thank all the attendees, participants of this icSoftComp 2022. I would also like to thank all the TPC members, general chairs, and advisory committee members. I would like to thank them also. I would like to thank Atul Patel for believing me and the freedom to organize this conference. Thank you very much, sir. I also would like to thank the management of the Chandra University of Science and Technology for providing their financial assistance to organize this conference. Thank you, everyone. I declare this conference closed here. Thank you very much.
Thank you, sir.